Welcome to the Explainer. Today, we're going to pull back the curtain and see what really makes Python tick. You know, one of the most popular programming languages on the entire planet.
So you've probably heard people say Python is super easy to learn, right? But to really get it, truly understand it, we've got to go deeper. We need to look under the hood at its core design.
Okay, so where do we start? Well, how about with Python's official description? Now, stick with me here. It sounds a little technical, I know. But it's basically the key to unlocking everything about how Python works.
Right here. These 4 things. They're like Python's secret identity. Each one is a clue to the fundamental design choices that make Python, well, feel like Python. So over the next few minutes, we're going to decode every single one.
All right, let's kick things off with 2 of those terms, high-level and dynamically typed. Both of these are really all about one single powerful idea, making programming feel way more intuitive, almost like you're just writing in plain English.
And this is what high level is all about. It means you tell the computer what you want, not how to do it. All that tedious, low-level stuff, memory addresses, hardware specifics, Python just takes care of it for you. It's like you get to be the architect, focusing on your big ideas, and Python handles all the plumbing.
And this is dynamic typing in action. It's so cool. Look, you never have to tell Python what type of variable is supposed to be. You can say x is 5, and Python's like, got it, an integer. Then on the very next line, you can say x is hello, and Python doesn't freak out. It just goes, no problem, now it's a string. It figures it all out on the fly, which makes coding so much faster and more flexible.
Okay, so that flexibility is a huge deal. Now let's talk about our next key term, interpreted. This really builds on that idea. You can almost think of the Python interpreter as a personal, simultaneous translator for your code.
See, a lot of languages compile everything into machine code all at once, before you even run it. Python's different. It has this cool pipeline. You write your code, right? That's step 1. Then, Python's lexer and parser read it and basically create a blueprint. After that, a compiler turns your code into this special intermediate language called bytecode. And finally, this thing called the Python virtual machine, or PVM, comes along and runs that bytecode, one instruction at a time.
And this is what that bytecode actually looks like. It might seem a little weird, but it's just a set of really simple instructions. This is the secret language that the PVM speaks. And because it's this intermediate step, it's what lets you run the exact same Python script on a Windows PC, a Mac, or a Linux machine without changing a single thing. Pretty neat, huh?
All right, on to our final term, garbage collected. This is one of my favorites. It basically means Python automatically cleans up after itself. It's like having a personal butler for your computer's memory. And this is a huge reason why Python is so easy to work with. In other languages, you often have to manually manage memory. You create something, you have to remember to destroy it. It's a pain. But with Python, you don't worry about it. It uses this really clever system called reference counting, where it just keeps track of how many things are using a piece of data.
Let me show you exactly how this works. Say we create a list and call it x. As soon as that list exists, Python starts a little counter for it. Right now, only x is pointing to it, so its reference count is 1. Simple enough?
Okay, now watch this, because this is the important part. If we make a new variable, y, and set it equal to x, we're not making a copy of the list. We're just making another signpost that points to the exact same list. So what happens to the counter? It just goes up to 2.
And here's the magic. The second that reference count hits 0, maybe we got rid of x and y. The moment nothing is pointing to that list anymore, Python's memory butler swoops in and poof, it's gone. The memory is freed up instantly. It's totally automatic, it's efficient, and it saves you from so many headaches and bugs. So this all sounds pretty perfect, doesn't it? An elegant, simple, automatic system. But here's the thing. In engineering, every great design has a trade-off. There's always a catch, and Python's catch is probably one of its most famous or infamous features.
It's called the Global Interpreter Lock, or the GIL for short. And what is it? Well, it's basically one simple rule. Only one thread can actually run Python bytecode at any single moment. The best way to think about it is like a one-lane highway for your code.
So why does this exist? Remember our helpful memory butler and that reference counting system? Well, the GL is what makes its job safe and simple.
By only letting one car on the highway at a time, it prevents two threads from messing with an object's reference count at the same time, which would be chaos. So it's a design choice that makes Python simpler and safer. But, and this is a big but, it has a major side effect on performance.
And this chart just says it all. Let's say you have a really intense task that's all on the CPU. Common sense says if you throw a second worker, a second thread at it, it should be twice as fast, right? Well, not in Python. Because of the GIL, they have to take turns on that one-lane highway. And the result is kind of mind-blowing. Two workers take the exact same amount of time as one. No speed up at all.
So when you put it all together, what's the big takeaway? It's this. Python's entire identity is built on a series of really deliberate choices. It chooses to be high-level and dynamic. It chooses to be interpreted. It chooses to manage memory for you. And it chooses the GIL. Over and over again, it trades a little bit of raw, parallel performance for things like developer happiness, safety, and simplicity. It's a philosophy, and it's all about empowering you, the programmer.
So you see, understanding why Python is the way it is, from its friendly syntax all the way down to the nitty-gritty of the GIL, that's the real key to mastering it. Now that you get the philosophy, the why behind it all, you're ready to tackle the language in a whole new way,